the difference between definite integral and indefinite integral is that indefinite integral has no upper and lower limits. So let's say, let's take a look at this indefinite integral. So we have the integral of 3x to the fourth minus x squared plus square root of x dx. There is no upper and lower limits. So when you find an indefinite integral, all you have to do is you take the antiderivative of the integrand. Another way to say this is you integrate the integrand and then you add a constant c at the end. So why do we add a constant c? Because when you take the derivative of your answer, the derivative of a constant is equals to 0. All right. Okay, so let's go ahead and find the first indefinite integral. So before we get into that, let's do a quick review. So we should do a quick review. So the first one in yellow, that is the integral of a constant k dx. So k is a constant, so the antiderivative of constant is kx, and then don't forget you have to add a c, and then this one is commonly used, so that is the power rule. So x raised to the n power, when you integrate, you take the n plus 1 and then you put the n plus 1 in the denominator, because when you take the derivative of that, you bring the n plus 1 down, n plus 1 minus 1 goes back to the integrand. And then this one is the integral of 1 over x. Don't use power rule because you will get a 0. You will get a 0 exponent. So when you see the integral of 1 over x, that is equal to the integral of absolute value of x. Is the absolute value optional? The answer is no. You have to stick with the absolute value until you can prove that the x is positive. So let's say the answer is ln absolute value of x squared. So if this is an absolute value, if this is an x squared, then you do not need the absolute value because x squared is guaranteed positive. And then for the absolute value, since ln of 0 and ln of negative is undefined, that's why we need the absolute value. The integral of e to the x is always e to the x. The integral of sine is equals to negative cosine. The integral of cosine is equals to negative sine. And then the integral of ln x dx. This one doesn't show up a lot. That is equals to x times ln x minus x plus c. But the integral of tangent has two different answers. The first one is ln absolute value of secant, and then the other one is negative ln absolute value of cosine. The reason of having this is secant is equals to 1 divided by cosine. So you have ln 1 divided by cosine, so that is ln 1 minus ln cosine. So since ln 1 is equals to 0, the minus stays in there. Right, so that's why there are two formulas for the integral of tangent. Okay, so let's begin solving problems. So I have 6 indefinite integrals. Let's do this one by one. The first one is integral 3x to the fourth minus x squared, and then plus the square root of x, which is x to the 1/2, right? And then dx, so this one, they are all power rule. So we have x 4 plus 1, and then we have 1 over 4 plus 1. Actually, there is a coefficient 3 in front of it. So instead of having a 4, we will put a 3 on top. And then minus, so this is x2 plus 1, and then 1 divided by that. And then this is x 1/2 plus 1. We have 1 divided by that. And then don't forget that there is a constant c at the end, because when you take the derivative of a constant, that is equals to 0. Okay, let's clean this up. So we have x to the 5th power, right? And then this is 3 over 5, and then minus x to the 3 1/3, and then plus x to the 3/2. This is a 2 over 3, and then you have a plus c. This is the final answer. How do I know this answer is correct? The best way to check your work is you take the derivative of that. That should bring you to back to this function, which is the integrand. Okay, so to check your work, take the derivative of that. The next one, let's do the one with divided by square root of x. Okay, let's change to a different color. So we have integral we have a 2x to the fifth. So you have 3 terms on top and then 1 terms in the denominator. So you are taking each term on top divided by the square root of x, which is x to the 1/2. So plus x to the 1/3 divided by x to the 1/2, and then minus 1 divided by x to the 1/2 dx. And then this one you have to work with the exponent on top, subtract the exponent on the bottom. So what is that equal to? That is equals to integral to 5 minus 1/2, that is 9/2, and then 1/3 minus 1/2, that is a -1/6, and then x to the 1/2 in the denominator, so that becomes x to the -1/2, and then dx. So now you can integrate. So what is that equal to? That is equals to x 9/2 plus 1, right? So 9/2 plus 1, you have 2 divided by that, and then plus x -1/6 plus 1, you have that in the denominator, and then plus x, minus, not plus, x to the -1/2 plus 1, and then you have that in the denominator. Alright, so what is that equal to? So the first one is x equals to 11/2, right? And then reciprocal of that, so that is 2 times 2, 4 divided by 11. Take the derivative of that, you should be able to get back to the integrand. And then plus x, so that is 5/6. This becomes 6/5. And then what else? Minus. So this is x to the what? X to the 1/2. Reciprocal is just a 2. And then don't forget that there is a plus c. Okay, so this is the antiderivative to the second integral. Okay, moving on. So as I move down, you won't see the top anymore. So now is a good time to take the screenshot so you don't need to rewind the video. Alright, moving on to the next one, we have integral x to the 4th and then times x minus 1 times x plus 5 dx. So the first step is I would just multiply the two parentheses. So this is x to the 4th, and then you have x squared, right? Plus 5 minus 1 plus 5x minus x, and then minus 5, you have a dx. And then you can subtract the 5x and the x, and then distribute the 4th. So you have integral x to the 4 plus 2 is 6. And then you have a 4, x to the 4 plus 1 is 5, the 5th power. And then minus 5, x to the 4th dx. So this is just a simple power rule, right? So this one, with a little bit of practice, you should be able to do it in one step. So this is the way I do this is 6 plus 1. And then 1 divided by that, 5 plus 1, and then 4 divided by that, minus x to the 5, 4 plus 1, and then 5 divided by 5 is 1. You can simply take the derivative of this to get back to the integrand. You should be able to do this in one step with a little bit of practice. And then you add a c to it, so that is the answer to the third integral. Alright, the next one we have some exponential function. Move down, we have integral 6e to the x minus 8e to the 2x dx. So what is the integral of 6e to the x? The integral of e to the x is still e to the x. So you have a 6e to the x. And then same thing for the next one, right? So it is supposed to be the same for the next one. So I am going to write this. So a e to the 2x plus c. Now, answer a question for me. Is this correct? Am I missing anything? You might see, okay, you left some space in there. Of course, you miss anything. Okay, what is missing? When you take the derivative of e to the 2x, what do you get? You get e to the 2x times 2 due to a chain rule. So when you take the derivative, there is a 2 in front of the a. But 2 times a is no longer equals to a. So how do we get rid of the extra 2? To get rid of the extra 2, you have to prepare a 1/2 in front of it. All right, so that is what I want you to learn from this problem. And then what do you get at the end? So at the end, you have 6e to the x minus 4e to the 2x plus c. So now when you take the derivative of this, you can get back to the integrand. Right? So e to the 2x times 2. So the 2 times 4, you will get your 8. All right, and then I want to do a what if. So what if, just a what if. So what if you have an integral of e to the negative 2x dx. So this one you have e to the negative 2x plus c, but when you take the derivative, there is an extra negative 2. Okay, to get rid of that, all I have to do is prepare for this. All right. Okay, moving on to the next problem. We have 2 problems left, so I will copy the problems for you anyway. So we have the 1 over x, and then we have the radical. Let's use red. So we have integral 1 over x, right? And then minus 2 divided by x squared plus 3 dx. Did I copy the problem right? Yep. Okay, integral of 1 over x. Is this a power rule? No. 1 over x, the integral, is ln absolute value of x. The absolute value is not optional. And then what else? So this is a minus 2x to the negative 2, right? So this one you have a x to the negative 2 plus 1 is negative 1, and then that is a positive 2, right? Take the derivative, bring the negative 1 down, you can get back to the integrand. And then plus 3x, and then plus c. This one, when you do your works online, they might not accept negative exponent. If so, then you have to put that as 2 divided by x. If they do not accept negative exponent, in my class, especially the written test, I accept negative exponent and radical exponent as well. Okay, let's do the last one. The last one, what do we have? The last one, we have a radical. We have a lot of radicals. So we have radical, we have integral, the square root of x to the third minus the fifth root of x dx. So this is x to the 3 over 2, right? The square root becomes a 1/2, and then the fifth root becomes a 1/5 power dx. And then integrate, so we have 3 over 2 plus 1, 1 divided by that, and then minus x to the 1/5 plus 1, 1 divided by that, and then what do we get? We have x, that is 5 over 2, right? 5 over 2 reciprocal minus x to the 6 over 5 reciprocal, and then you add c at the end. And then this is the last integral that we have to evaluate. All right, so that is the end of this video. If you like the way I teach this integration, give me a thumbs up, a subscribe, and I will see you all in the next video. Signing out.